Hey guys, my name's Adrian. I'm a maths teacher out here in Sydney, and today I'm going to be doing the entire Standard Maths 2022 HSC paper. Let's go. Okay, so here we've got the paper, 2.5 hours, we've got 15 marks multiple choice, and 85 marks short answer. Let's get into it. Question 1, which graph represents a negatively skewed distribution? Okay, looking at all of these, what do I got? I've got a symmetrical, it looks like, a straight line which is uniform. I have one where the tail's facing the positive end, so that's positively skewed. That means C, where the tail is facing the negative end, has to be my negative skew. Question 2, which of the following could be the graph of y is equal to minus 2x plus 2? Okay, well, this is in the form of y equals mx plus b, where m is my gradient, so m here is minus 2. And that tells me the direction of my line. So negative gradients look like this. So I can rule out C and D. I also know that my y-intercept is 2. That means my line has to cross the y-axis in the positive region. So looking at all these, the only one I can say is A. Question 3. The network diagram shows the time needed for each step in order to complete a project. Which is the critical path to complete the project? All right, so I know my critical path is when my earliest start time is equal to my latest start time. So highlighting all of those, 0, 0, 3, 3, 19, 19, and 22, 22, I can just backtrack to work out which is my critical path. So it looks like it's going to be A, D, and G. Okay, cool. Question 4. Lily wanted to estimate the number of fish in a lake. She randomly captures 30 fish, then tagged and released them. 1 week later, she randomly captured 40 fish from the same lake. She found that 12 of these 40 fish were tagged. What is the best estimate for the total number of fish in this lake? Okay, so for these capture-recapture questions, unfortunately, they don't give you the formula on the formula sheet, so you kind of need to remember what to do here. So how we find it is basically, we want to write down how much we tagged, or how much she tagged the first time, and we want to divide that by the total, which we don't know, or the total estimate for the lake, the number of fish in this lake. Now that's going to be equal to the number she caught the second time and tagged, so that's 12, divided by the total of number of fish that she caught the second time. Now it's just a basic equation. We can cross multiply. So x times 12, 30 times 40. So 30 times 40 is 1,200. X times 12 is 12x. Divide both sides by 12. So x is going to be equal to 100. So that's D. Okay, moving on. Question 5. Consider the following data set. Which row of the table shows how the median and mean are affected when a score of 5 is added to the data set? Okay, so we've got 4 options here, and each one talks about whether median either changes or doesn't, and same with the mean. So let's start with the mean first, because I think that's the most straightforward one. So mean is just average. Now, if I add 5 to the data set, that is obviously going to bring the average of that data set down. So if you want to put it into context, let's say these are exam results, and someone new has done the test and scored 5, hopefully not you, and that will bring the average down. So the mean is going to change. Now for the median. So without the 5, ignoring that for a second, what is the median? So the median is the middle number, and if I look at my data set, I think it's going to be in between 17 and 17. Now if it's in between two numbers, it's going to be the average of those two numbers, which happens to also be 17. Okay, so what happens if I add a 5 to the end? Well, if I add a 5 to the end, my median is going to shift to the left. But does that change anything? So looking now, I've got 1, 2, 3, 4, 5, 6, 7. In order to make the median, I need the same number on either side. So I think my new median is going to be 17, because that leaves me with 3 numbers on either side of 17. So as you can tell, the median is going to stay the same. So which one is that? That is 5D, stays the same and changes. All right, cool. Question 6, what is 20 minutes to 1/3 of a day expressed as a ratio in its simplest form? So in this case, we've got two different units. We've got minutes and part of a day. So we need to make those two things the same. I think it's going to be easier to make the 1/3 of a day into minutes easier. So I know one day is 24 hours. So 1/3 of a day, dividing both sides by 3, will be 8 hours. So 8 hours is going to be equal to 480 minutes because I'm timesing that by 60. And now I just need to compare the original 20 minutes to 480, cross off a 0, 2 to 48, divide both sides by 2, so 1 to 24. That is 6B. 7, Tian is paid $20.45 per hour as well as a meal allowance of $16.20 per day. What are Tian's total earnings if she works 9 hours per day for 5 days? Okay, seems pretty straightforward. That much per hour for 9 hours for 5 days, and she gets a meal allowance. So working this out, for one day, she's going to be $20.45 per hour times 9 hours. And I need to multiply that by, I need to add $16.20 for the day. And because she's doing this 5 days, I need to multiply that by 5. Okay, so let's do this. I've got 20.45 times 9, that's equal to that, plus $16.20, which is $225. And now I need to multiply that by 5, so that gives me $1,001.25. So my answer is C. Okay, question 8. What true bearing is the same as S 48 degrees west? So it would be advisable, in my opinion, to draw a little diagram. Now, where is south 48 degrees west going to be? It's going to be somewhere here, okay? Because you need to start at west and you need to rotate. Sorry, you need to start at south and you need to rotate in the western direction, 48 degrees. Now they want the bearing, so if I put my numbers in here, that should be 90, 180, 270, 360. You can clearly see it's going to be 180 plus 45. Okay, so 180 plus 45, 48. That's 228. Cool. 9. An object is projected vertically into the air. Its height h meters above the ground after t seconds is given by that formula. H is equal to minus 5t squared plus 80t. For how long is the object at a height of 300 meters or more above the ground? Okay, so I just want to know how long it's above 300. So I can clearly see here that 300 is on my y-axis. I'm just going to draw a horizontal line across that. Now it's not the most accurate line, but you can kind of see it's going to intersect at 6 seconds and it's going to intersect at 10 seconds. That must mean it's going to be in the air for 4 seconds, so 10 minus 4, 10 minus 6. So it's just that area there. Question 10, Alex purchased 800 shares. The total cost was $2.60 per share. Alex sold the shares 1 year later for $3.40 and $3.40 each and paid a fee of $24.95 for selling the shares. What profit did Alex make on these shares? Okay, so when it comes to these questions of buying and selling, I like to draw a table out. Let me go back to blue. Just a small table that's going to have what he sold it for, what he bought it for, and then also the brokerage. So I'm basically going to work out what he sold it for. So he's got 800 and he's selling them for $3.40 each. He bought them for $2.60 and the brokerage is $24.95. So what it's going to be that, take away that to work out his profit. Okay, so let's work that out. So what do I have? 800 times $3.40 minus 800 times $2.60 minus the brokerage, $24.95, and that leaves me with $615.08. So my answer here is 10B, or 5 I should say. Okay, question 11. In 10 years, the future value of investment will be $150,000. The interest rate is 4% per annum, compounded half yearly. What equation will give the present value of the investment? So clearly we're looking at a future value or compound interest question. That's our formula, which is on the formula sheet. We need to find the present value, which means we need to move all of this other stuff to the other side. The way to do that would be divide both sides by that. That's my present value. And now it's just about putting the numbers in. So my future value is 150,000 divided by 1 plus the rate. So the rate's 4% per annum, but it's compounded half yearly. That means we need to divide 4% by 2. 4% is 0.04, so divide by 2 is 0.02. And I need to work out how many half years there are in 10 years, or how many 6 months there are. So it's going to be 2 times 10, that's 20. Looking at all my answers, it'll be 11D, I think. Okay, so almost done. 12. For a particular course, the recorded data show a relationship between the number of hours studied per week and the marks achieved out of 100. A least square regression line is fitted to this data set. The equation of the line is given by this formula here, where M is the predicted mark and H is the number of hours studied per week. Based on the regression equation, which of the following is correct regarding the predicted mark of a student? Okay, so quite a bit of language there, but let's try and work this out one at a time. It will be 3 for 0 hours of study per week. So they're saying the mark will be 3 for no study. Well, let's test this out. No study is H equals 0 for 0 hours. Putting in the formula, I'll have M is equal to 20 plus 3 times 0. So that's going to be equal to 20. So if you study for 0 hours, you're still getting a 20. So this has to be incorrect. Question B, you'll get 20 marks for 0 hours worth of study. Well, it looks like we just worked that out here. So that has to be correct, 12B. Which is lucky, so we don't have to work out C and D. Okay, normal distribution question. A random variable is normally distributed with a mean of 0 and a standard deviation of 1. The table gives a probability that this random variable lies below Z for some positive values of Z. So here we've got a table of some Z scores and its probabilities. Just to put this into context, what it's saying, for example, let's say your height had a Z score of 1.99. That means if I randomly choose someone from a population, there's a 97.67 chance I'll be shorter than you. So you're obviously super tall. Okay, now the probability values given in the table are represented by the shaded area in the following diagram. What is the probability that a normally distributed random variable with a mean of 0 and a standard deviation of 1 lie between 0 and 1.94? Okay, now they're giving us this diagram because they want you to use it. If I put in my Z score of 1.94 here, what they're saying is anything below that point, so all that shaded bit, that has a probability of 0.9767 of being shorter than you, as the example I just gave. But they want to know what's the probability that if I choose someone random, they're going to be within the mean and your height. So just that bit there. Now, because normally distributed data is symmetrical, I know that anything left of this blue dotted line is going to be 0.5. So to work out the difference, it's going to be 1.94, it's going to be this z-score 0.9738, take away 0.5. So what's that? That's 0.4738. So I think my answer has to be B here. Okay, cool. Two more. Which of the following correctly expresses x as the subject of the equation? So let's just rearrange this. So as a rule of thumb, you always want to get rid of the denominator. So I'm going to multiply both sides by 2 to get 2y is equal to ax take away b. I'm trying to get x by itself, so I'm going to move the furthest thing away from it. So I move b over. 2y plus b is equal to ax. And finally, divide both sides by the a. And it looks like 14a is my answer. Okay, cool. Last one. The cumulative frequency graphs show the distribution of the number of movie downloads made by 100 people in 1 month. Which box plot represents the same data as displayed in the cumulative frequency graph? Okay, so think back to box plots. Box plots tell us an important kind of information in terms of a 5-figure summary. So I've got a lowest, Q1, Q2, or the median, Q3, and the highest. So let's have a look at my cumulative frequency graph here. Now they made it easier for us by telling us there's 100 people, which means our cumulative frequency graph is just literally going to be working on a scale of 100%. So I know my lowest here is 2, as I can see here. My lowest score is 2 and my highest is 9. So I can already fill that in. Okay, now my Q2 or my median is going to be in the middle between 0 and 100%, so that's 50%. So I draw a line until it hits the ogive, or ogive, never sure how you actually say it, but you hit that line and go down. So that is going to be 6. Q1 is just the median of the first half, or 25%, so that's going to be somewhere here at 3. And Q3 is 75%, so that's going to be just below 80 there. And it's going to hit 7 as our Q3. And now it's just a matter of matching it up. So let's say they all have highs and lows of 2 and 9. This one has a median of 6, but doesn't have a Q1 of 3, so it can't be A. This one doesn't have a median of 6, can't be that one. This one has a median of 6, Q1 of 3, and Q1 of 3 and Q3 of 7. So I think that is my answer. Okay, cool. That's multi-choice done. Time for the short answer. Let's go. Okay. As you can tell, it looked different. Something came up before, but now we're back, so let's finish this. Okay, question 16. Tom is 25 years old and likes to keep fit by exercising. Use this formula to find his maximum heart rate, beats per minute. Now the maximum heart rate is equal to 220 minus age in years. Tom's maximum heart rate in BPM is, okay, well he's 25 years old, so according to this formula, it will be 220 minus 25. I think that's 195. It's pretty straightforward. B, Tom will get most of the benefit from this exercise if his heart rate is between 50% and 85% of his maximum heart rate. Between what two heart rates should Tom be aiming for to get the most benefit from his exercise? It's a pretty straightforward question. You just need to find a percentage of the min and max, and obviously just a range. So we've got 50% and we've got 85%. Now you'll notice I really like putting stuff in tables, just makes things easier to read. So this will be 50% times 195, and this will be 85% times 195, I think. Yep, let's pull up the calculator. Okay, so what do we have? We've got 0.5 times 195. That's 97.5. And we've got 0.85 times 195, so that's 165.75. So that's our range there. Okay, question 17. The numbers 1, 2, 3, 4, 5, 6 are each written on separate cards. Amy has cards 1, 3, 5, Bob has cards 2, 4, 6. They play a game in which each person randomly chooses one of their own cards and compares it with the other person's card. The person with the higher card wins. A partially tree diagram is shown below. So here we've got all of Amy's choices, 1, 3, 5, and here are all of Bob's cards. So Bob has 2, 4, 6, 2, 4, 6, 2, 4, 6. And we want to complete the tree diagram and find the probability that Bob wins. Okay, so I'm going to list out the sample space over here. 1, 2, 1, 4, 1, 6, 3, 2, 3, 4, 3, 6. 5, 2, 5, 4, 5, 6. And we want to look at all the cases where the numbers on the right hand side of this column are bigger than the left hand side. So going through this, that's yes, 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 no, yes, yes, no, no, yes. So how many do we have? We've got 1, 2, 3, 4, 5, 6. 6 over 3, 6, 9. So we've got 6 over 9. That's 2/3. So Bob wins 2/3 of the time. Question B, suppose Amy and Bob play this game 30 times. How many times would you expect Bob to win? So we have Bob's expected win rate, which is 2/3. And we want to find how often he'll win if he plays 30 times. Well, that simplifies to 20 times. Okay, next one. 18. The marks in a test were normally distributed. The mean mark was 60 and the standard deviation was 15. What was the percentage of marks higher than 90? Okay, so for all normal distribution questions, I like to draw a diagram. And that diagram basically just looks like this. Let's just pull this a bit further down. So I've got a mean, which will be right in the middle, of 60, and I have a standard deviation of 15. And I want to know what percentage of marks are higher than 90. Now, because I'm only working on numbers which are greater than 60, I'm only going to write in my standard deviations above 60. So 60 plus 15 is 75, plus another 15 is 90. So we are, as you can see, 2 standard deviations above the mean. Two standard deviations above the mean. So if you think back to your kind of the separation of percentages, this is 34%. And this is 13.5%. So what percentage of marks are higher? Well, I know that this thing here is 50%, so anything less than that. And I just want to know how many are above here. So it has to be 100% minus 13.5% minus 34 minus 50%. So let's work that out. So I've got 100 minus 13.5 minus 34 minus 50. So my answer is 2.5%. Now, just for the sake of showing you how I would do this if it were more. So remember up until here, that is another, now if you've got 2.5% left, it's 2.35 here. Write that properly, 2.35% here and 0.15. I would really encourage you to actually just remember this, literally just rote learn it, as opposed to using what you're given on the formula sheet, which is 68, 95, 99.7. It's just much easier to kind of break things down with those four numbers. And you only have to remember 1/2 because it's symmetrical. Okay, 19. The table shows the type of customer complaints received by an online business in a month. So there you can see you've got a frequency column, all the complaints, the cumulative frequency, so basically adding up all these as you go, and the cumulative percentage, so all of these as a percentage out of 100. What are the values for A and B? Okay, so I know I'm adding these up, these frequency ups as I go, so 98, 98. So 98 plus 62 should give me A. So what's that? 98. Maybe I'll put it in here so you can see. Plus 62. So that's 160. Now what is B? Okay, so B is just my cumulative percentage. What it's trying to say is what fraction of 98 is it of the total as a percentage? So that's 49. Now, if you didn't know in a test, you can kind of just verify. So 98 divided by 200 times 100, that gives 49%. So that's how you would get your cumulative percentage. So to get B, it's going to be 192 divided by 200. 192 divided by 200 times 100, so that's 96%, or just 96 in this case. Let's get rid of that. From the data from the table is shown on a Pareto chart. So they've basically just graphed all that data into one of these Pareto charts. The manager will address 80% of the complaints. Which types of complaints will the manager address? Okay, well, these columns refer to the frequency, and this kind of line graph is just adding these columns cumulatively till we get to 100%, and they refer to the right hand side. Okay, so the manager will address 80%, so I just look at 80%. 80% hits a delivery fee, so we're going to be talking about these two things. So stock shortage and delivery fee. Okay, cool. All right, networks. The table below shows distances in kilometers between a number of towns. So we've got a matrix here, shows all the connections. Using the vertices given, draw a weighted network diagram to represent the information shown in the table. Okay, so S connects to Y, 280. S connects to B, 275. C connects to Y, 60. C connects to B, 150. Y connects to S, 280, we've got that. Y connects to C, 60, we've also got that. Y connects to M, 530. B connects to S, 275. Do we have that? Yep. B connects to C, 150, we've got that. B connects to M, 790. So B connects to M, 790. M connects to Y, 530, we've got that. M connects to B, 790, we've also got that. All right, done. A tourist wishes to visit each town. Draw the minimum spanning tree, which will allow for this and determine its length. Okay, so depending on what algorithm you're going to use to find the minimum spanning tree, it shouldn't matter because it seems there's only going to be one answer. So I'm going to go for prims, which is basically you start at a vertex and you choose the next smallest edge that's already connected. So if I start at S, the next smallest one would have to be 275. Going from here, the next smallest connected one would have to be 150. Next smallest would have to be 60. And finally, next smallest, I think, is going to be 530. Okay, now remember, you can't make a loop in a minimum spanning tree, so you wouldn't need that one. Okay, so redrawing this. and working out my length, 275, 150, 60, 530, 530. So I'm going to add all these up. $275 plus 150 plus 60 plus 530. So that's 1015. 1015. Okay, done. Moving on. A real estate agent's commission for selling houses 2% on the first 800,000 of the sale price and 1.5% of any amount over 800,000. Calculate the commission earned in selling a house for $1.5 million. Okay, it's a pretty straightforward question. Basically, you're getting different commission rates whether you're above or below 800,000. So it makes sense to split this with the two numbers that actually add up to that. So if my maths in my head is correct, it's 800,000 plus 750,000. This bit here is going to be getting 2%. And this bit here is only going to get 1.5%. And that's a straight up calculation. So we've got 0.02 times 800,000 plus 750,000 times 0.015. So my final answer here is 27250. Okay, cool. Question 22. The formula C is equal to 100N plus B is used to calculate the cost of producing laptops, where C is the cost in dollars, N is the number of laptops produced, and B is the fixed cost in dollars. Find the cost when 1,943 laptops are produced and the fixed cost is 20,180. Okay, so quite a bit of words here, but let's have a look. So what did they say? They said C is the number of laptops, B is the fixed cost. Okay, so we're just going to substitute this in the equation. This will be N for laptops, this will be B for fixed costs. So C is 100 times 1943 plus 20180. So we've got 100, let's delete that, 100, 1943, plus the fixed cost 20180. So the final answer here, 214480. Write that properly. Question B, some laptops have extra added features. The formula to calculate the production cost for this is, so they've given us another equation, C is equal to 100N plus AN plus 20180, where A is the additional cost in dollars per laptop produced. Find the number of laptops produced if the additional cost is $26 per laptop, and the total production cost is $97,040. Okay, so we're trying to find N here for the number of laptops produced. So I'm literally just going to substitute this in. This stands for A, as it says, A is the additional cost in dollars. Okay, so we've got 97040 equals to 100 N plus 26N plus 20180. So we've got an equation here. 97040 is equal to 126N at like terms. Subtract away 20180 from both sides. I'm not good enough to do that in my head. So 97040 7040 minus 20180. That's 76860 equals 126n. Divide by 126. So n is equal to 610 laptops. All right, cool. Let's keep going. 23. A teacher surveyed the number of students in her Year 8 class to investigate the relationship between the average number of hours of phone use per day and the average number of hours of sleep per day. The results are shown in the scatter plot. So on the y-axis, you've got average amount of sleep and average amount of phone use. So according to this, the more phone use you use, the less average amount of sleep you're going to get. The data for two new students, Alinta and Birani, are shown in the table below. Plot the results on the scatter plot. Okay, so Alinta uses her phone for 4 hours per day and sleeps an average of 8. So where's that? So 4, and it's going to hit 8 there. Birani is 0 and 10.5, so this is obviously someone that doesn't exist, who doesn't use their phone. So 10.5 is going to be up there. Okay, that's done. Question B, if I'm fitting the line of best fit by I on the scatter plot, estimate the average number of hours of sleep per day for a student who uses the phone for an average hour of 2. Okay, so for line of best fit, obviously there's a bit of leeway here, but you kind of want to get the same amount of dots above and below the line. So let's have a look. If I draw a line, something looking like that. That would give me 2 above, 5 below, so maybe it needs to be a bit more. I think that looks okay, so let's see. Where should I put that? So right now, what do I have? I have 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3. So kind of quite off here. So let's see if I can adjust this. Now I have 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Okay, I think that's pretty good fit. So take a bit of time when you're actually in the exam doing this thing. And I need to get the average number of sleep per day for someone that uses their phone for 2 hours. So here, right across. Okay, so it looks pretty nice there. I think it's going to be 9 hours of sleep. So roughly 9 hours, I would say. Question 24. A student believes that the time it takes for an ice cube to melt varies inversely with the room temperature. A student observes that at room temperature of 15 degrees, it takes 12 minutes for an ice cube to melt. Find an equation relating m and t. So it's quite a straightforward inverse variation. Now, inverse variation always looks like this, k on x, but we just need to replace the letters. So m is going to be k over t. We need to find k, is always the first step. So my m stands for minutes, which will be 12 minutes, is equal to k over 15 degrees. K is equal to 15 times 12. What's that? 15 times 12 is 180. So therefore, m is 180 over t. All right, cool. Next question. By first completing the table of values, graph the relationship between temperature and time for t is equal to 5 to t equals 30. Okay, it's pretty straightforward. We've just got to fill this table in using this formula that we just found. Okay. So first one is 180 divided by 5. That gives me 36. Then 180 divided by 15, that's 12. And 180 divided by 30 is 6. So plotting that, $5.36 looks like it belongs here. $15.12 is somewhere here. And 36 is somewhere here. Now I just got to connect the dots. Missed that last one a little bit, but I think you get the point. All right, cool. All right, 25. A table shows the future value of an annuity of $1. So here we get given a table of future values and the interest factors. Zal is saving for a trip and estimates he will need $15,000. He opens an account earning 3% per annum compounded annually. How much does Zal need to deposit every year if he wishes to have enough money for his trip in 4 years' time? Okay, so this question is pretty straightforward because not only is this already in, or not only have they given us the table, but it's also compounding annually and the percents per annum, so there's no conversion. Now, he's doing this for 4 years, so 3% for 4 years is going to give me an interest factor of 4.184. And I want to know how much he needs to deposit every year. So what is the annuity to get him to $15,000? So it has to be 15,000 divided by the interest factor. So 15,000 divided by 4.184, that is 3,585.09 to the nearest cent. B, how much interest will Zal earn on his investment over 4 years? Give your answer to the nearest dollar. Okay, so a lot of people get confused here and they kind of freak out over the whole interest thing and they start doing compound interest formula, and that's not the way to go. When you get given an annuity, it usually is going to be just however often he's depositing it times by how long he's putting it in for. So in this case, he's doing 3,585.09 per year, and he's doing that for 4 years. So in total, what's he going to have? In total, he should have 14,340.34. So he's only depositing $14,340, but at the end, he's going to have 15,000. So that means the difference between that and 15,000 is going to be our interest. So 15,000 minus 14,340.34. So our interest is 659.66. Okay. All right, 26, trig. The diagram shows two right angles, ABC, ABD. One here, and ABD, so big one nested in a small one, or small one nested in a big one. Calculate the angle theta to the nearest minute. Okay, so let's try and work this out. Whenever I do these questions, I don't exactly know how I'm going to get to the final answer, but I'll start filling in information that I can see straight away. So for example, that angle is 41, so this angle has to be 180 minus 41, which is 180 minus 41, so that's 139. What else do I know? Well, if I look at this triangle here, I'm probably going to have to do something like a sine rule or cosine rule. I see that this side is opposite this angle. And I also see that this angle could be opposite this side, but I don't have anything there. Now I could use this triangle ABC to actually get me there. So if I label that X, think back to simple SOHCAHTOA, you've got adjacent hypotenuse. So finding X would be cos 41 is equal to 35 over X. Now when X, or the pronumeral is in the bottom like this, you can just switch it over with the cos 41. So what's that? So that's going to be 35 over cos 41. So 46.37. Let's just do a few decimal places. That gives me that. And now I can actually attack this by doing that. So it's going to be the sine rule. So finding an angle is just sine theta over, I should do this properly. So sine A over A is equal to sine B over B. All right, so sine theta over 46.3755, what we just found. One sine 139 over 93. Multiply both sides by 46.3755. And I just basically want to shift sign all of that. So shift sign. (46.3755) times sine 139 over 93, and my final answer is 19 degrees and 6 minutes, rounding it up to the nearest minute. All right, nice. Let's keep going. 27, a company purchases machines for $50,000. The two methods of depreciation being considered are declining balance method and straight line. For the declining balance method, the salvage value of the machine after n years is given by this formula, where S is a salvage value and V0 is the initial cost of the asset. What is the annual rate of depreciation used in this formula? Okay, so declining balance actually gets given to you on the formula sheet, so you should be able to work this out. 1 minus the rate to the power of n, very similar to compound interest, but with a minus. Now, that number is 0.8, but initially it's got to be 1 minus the rate. So in order to get 80%, the depreciation has to be 20%. Okay, I calculate the salvage value of the machine after 3 years based on the given formula. So that's just straight up substituting. So initially it was $50,000. And it's going to be 0.80 to the power of 3. $50,000, 0.8 to the power of 3. So it's 25,600. It's a nice number. Okay, done. B, for the straight line method, the value of the machine depreciates at a rate of 12.2% of the purchase price each year. When will the value of the machine using this method be equal to the salvage value found in part A, II? So when is it going to be the same as that? Okay, so there's a few things here. It depreciates by 12.2% of the initial price. So the initial price was $50,000. And it goes down by 12.2% of that. So let's find out what that is. That is 6,100 per year. And we want to know how long it's going to take to equal 25,600. Well, straight lines is quite straightforward. We just want to know when our machine's going to hit that. Initially it was 50,000, and I want to minus 6,100 times the number of years it's gone down and solve it like an equation. Now I need to get this to the other side because it's negative, so I'm going to switch that position. So 6,100 n is equal to 50,000 minus 25,600. That's 24,400 divided by 6,100. So once again, n is equal to a nice round number of 4 years. Okay. Whew. Moving on. Question 28. A dam is in the shape of triangular prism, which is 50 meters long. As shown, both ends of the dam A, B, C, D, E, F are isosceles with equal side lengths of 25. The included angles BAC and EDF are both 150. So you can kind of see all that information there. Calculate the number of liters of water the dam will hold when full. Okay, so we're clearly talking about a volume problem here. So volume is always going to be the area of the face times how deep it is. Here I'll just call it height. Now we've got that. The height's going to be 50 because you can see that's how far back it's going. And we just need to find the area of this face there. So the area of that is obviously a triangle or a non-right angle triangle. So half AB sine C. So area of ABC will be 1/2 25 times 25 sine 150. That gives me the area. Now to find the volume, I just want to multiply that by 50. So I'll put this in the calculator in one go. Okay, so 1/2 times 25 times 25 times sine 150 times 50 is 7,821.50. Okay, now this is in meters cubed. Think back to your conversions. 1 cubic meter is 1 kiloliter. So it's literally just changing the letters. Now, because they want it in liters, to get the kiloliters to liters, you multiply that by 1,000. So let's get this back up. Times 1,000. So we're gonna have 7812500 liters. So 7 million liters. Okay, nice. All right, 29. Sydney is 10 hours ahead of UTC, Coordinated Universal Time, and New York is 5 hours behind. Tony travels from Sydney to New York. He leaves Sydney at 8:20 on a Wednesday local time and flies non-stop. The flight takes 20 hours, 24 minutes. What time is it in New York when the plane lands? Okay, so I personally would never be able to do this without drawing a diagram. So let's start with that. Now I'm drawing this kind of as a number line where UTC 0 is there. Now I know Sydney is +10, as it says in the question, and New York is -5. So as you can clearly see, the time difference is going to be 15 hours. Okay, so he's leaving Sydney at 8:20 on a Wednesday. At 8:20 p.m. on a Wednesday. Now, before I even do anything that relates to the flight time, I actually just want to work out what is the time in New York when it's 8:20 on a Wednesday in Sydney. Okay, so I know New York is 15 hours behind. So what I like to do is I kind of work in 12-hour blocks if I can. So 8 p.m. on a Wednesday, and I want to go back 12 hours first. That's going to get me at 8 a.m. on the Wednesday. And now I need to go another 3 hours to make up the 15. So it's going to be 5 a.m. on a Wednesday. So it's still Wednesday in New York, but it's 5:20 a.m. Okay, now once I've done this, then I want to add on the 20 hours, 24 minutes. So here is where I add on 20 hours and 24 minutes. Now, once again, try and work in 12-hour blocks. So 12 hours from 5 a.m. gets me to 5:20 p.m. I have another 8 hours to get to 20 hours, so plus 8 hours. So you've got to do a bit of thinking here. It's going to be 4, 5, 6, 7 hours to get to midnight, 12:20, plus another 1 hour, so it's going to be 1:20 a.m. on a Thursday. And now we're just going to add the 24 minutes. So 1:48 a.m. on a Thursday. Okay, so I'm pretty sure that's right. So take the time to draw a nice diagram, and it's definitely going to help you. Okay, question 30. Eli is choosing between two investment options. So option A, depositing a single sum of $40,000 today, earning interest 1.2% per annum compounded monthly. And option 2, depositing $1,000 at the end of each quarter, earning interest at 2.4% per annum compounded quarterly. Okay, so what's the difference here? Well, this thing here is just straight up compound interest, whereas our second option is an annuity because we're putting money in at regular contributions. Okay, so what is the value of Eli's investment after 10 years using option 1? So option 1 should just be our formula, future value formula. So his present value is $40,000, 1 plus the rate, which is 1.2% per 12 months. And he's doing this for 10 years, I think. 10 years times 12, okay? So let's have a look. 40,000, 1 plus 1.2. I don't actually know where the percentage sign is here, so let's just change that to 0.012 over 12 to the power of 10 times 12. So our future value is $45,097.17. Okay, question B. What is the difference between the future value after 10 years using option 1 and option 2? Okay, so option 2, we're going to need to involve this future value, or this annuity table. So let's look at it. He's depositing $1,000 at the end of each quarter, earning 2.4%. So we need to convert that 2.4% into per quarter. So that's 0.006. So we're looking here. And how many quarters are in 10 years? Well, it's going to be 40, right? 10 times 4. So that's our number there. So let's work it out. He is doing $1,000 times 45.05630. So 1,000 times 45.05630. So option 2, I should actually write this out clearly. So 45,056.30. Option 2. So what's the difference? Well, it looks like option 1 is going to generate slightly more money. So let's do that. Option 1 minus option 2, 45097.17 minus this number here. So you can tell I'm lazy at writing that out again. So the difference is $40.87. So slightly more money with the first option. Okay. Question 31. A wildlife park has 5 main attractions, A, B, C, D, E, connected by directional paths. A simple network is drawn to represent the flow through the park's paths. The number of visitors who can access each path at any one time is shown. Okay, question A, what is the capacity of the cut shown? So let's see if there's any invalid going from bottom to top. Now, it looks like that will be invalid because the arrow is kind of going backwards. And in any case, it's kind of coming through here anyway. So the only ones we need to count is this one, and this one. So 10 plus 20 plus 10 is 40, I think. That's our capacity. B, by showing a suitable cut on the diagram below, explain why the network's current maximum flow capacity is less than 40. So we basically need to find, now remember, max cut is equal to minimum flow. So we just got to find a cut which is equivalent to 40. Okay, so, or is less than 40, I should say. So smaller than 40. So that's 40 there. We just found that's 40. What's this one? 15, 25, don't count that one. 10, that's 35. So I think that's our answer there because these won't work. Okay, so our cut is going to be here because that will be invalid, that 10. So 15 plus 10 is 25 plus 10 is 35. So 15 plus 10 plus 10 is 35, which is less than 40. Okay, C, one path is to be increasing capacity, so the overall maximum flow will be 40 visitors at any one time. Which path could be increased and by how much? There's 40 here, right? And we found that there's a blockage somewhere along this path here. So we're really only looking at this one, and this one. Okay, now looking at AE and DE, which go into the same vertex here, E, well, that's a total of 35. And down here, it's got an output of 30. So we could increase EB here by 5, which would let this basically squeeze that extra 5 through here. Okay, so what we need to do here for C is we basically need to increase one of these 3 edges because that's where the minimum cut doesn't meet our requirement of 40 visitors. So if we look at these systematically, i.e. one at a time, this edge and this edge, A, E, and D, both go into vertex E, which adds up to an input of 35. And we've got an output here of 30. So it's already maxed out. So if we're looking here 10 CB, that actually goes into the sink at 20. So I can increase this one by 5 because there's actually room to get that through. So CB increase by 5 to match up to 40. Okay, that was a toughie. Let's keep going. The diagram shows a park consisting of a rectangle and a semicircle. The semicircle has a radius of 100 meters. The dimensions of the rectangle are 200 meters and 250 meters. A lake occupies a section of the park as shown. The rest of the park is grass section. Some measurements from the end of the grass section to the edge of the lake are also shown. Okay, so there's a diagram, and it says using 2 applications of trapezoidal rule, calculate the approximate area of the grass section. Okay, that's quite straightforward, I think. So we've got area 1 here, area 2 here. Oh. So 1, 2. Okay, so area 1 will be 1/2 A plus B, which is our parallel sides, times our height. Now this is split evenly over 200, so that has to be 100, that has to be 100, so our height is 100. Our area 2 similarly is our parallel sides, 150 plus 250 times 100, and we just got to add these two together. So 1/2 160 plus 150 times 100 plus, okay, 1/2 150 plus 250 times 100. Okay, so our area is 35,500 meters squared. Hence calculate the approximate area of the lake. Okay, so we just need this shaded bit there. All right, now that there at the top is clearly a semicircle. That's easy enough to find. But this bit here, well, that bit there is just going to be our rectangle minus what we found using trapezoidal rule. So for this bit here, it's going to be big rectangle, which is 250 by 200, minus what we found in part A, so 35,500. So what's that equal to? $250 times 200 minus 35,500. That's 14,500. And we need to add on the semicircle. All right, so the semicircle over here is going to be 1/2 pi r squared. So what's our radius? Our radius is 100. They've given that to us. So 1/2 100 squared. Let's work that out. 1/2 times pi times 100 squared. So 15707.96. So my total area here, oh, I shouldn't have got rid of that yet, but never mind. So total area 14,500 plus 15,707.96. So that's equal to 30207.96 meters squared. Okay, moving on. All right, bearings. So the diagram shows an aeroplane that was flying towards the airport A on a bearing of 135 degrees true north. When it was at point O, 20 kilometers away from the airport A, the flight course was changed. The aeroplane landed at port airport B directly south of O. The distance from O to B is 50 kilometers. So it's gone from here to here, and it's also changed course to go to B. A, show the distance between the airport A and the airport B is 38.5 kilometers, correct to one decimal place. Okay, so let's put in a bit of information here. We know that it's flying on a bearing of 135. So that there is 135 degrees, which means that inside has to be 180 minus 135, so 45 degrees. I'm trying to find the distance AB. So if I label that X, hopefully you can see this is going to be a cosine rule. So here we go. X squared is equal to A squared plus B squared minus 2AB cos 45. And we're going to square root whatever answer we get here. So 50 squared plus 20 squared minus 2 times 50 times 20 times cos 45 equals square root answer. Nice, 38.5 kilometers. So I'm just going to put that back in here. 38.5 kilometers. Okay, B, use the sine rule to find angle OBA. Okay, so we were trying to find this angle here. And it looks like we can clearly do a straight sine rule. Okay, so we've got sine theta over 20 because it's opposite. And we've got sine 45 over 38.5. Sine theta will be 20 times this. And obviously shift sine to find the angle. 20 times sine 45 over 38.5 equals shift sine answer. So theta is equal to nearest degree. All right, so that's 22 degrees to the nearest degree. Okay, so once again, I'm going to put that back in. 22 degrees. C, what is the bearing of the airport B from airport A? So what is the bearing of B from A? All right, so they want this one, right? That was dodgy. So I want to know what is that bearing there. Okay, so what do I know? Well, I know that this angle up here is going to be all co-interior with this one, and also alternate. So this angle in here will be 45 degrees. What's this little angle in here? Well, it has to be 180 minus 45 minus 22. So that's 113. So my bearing has to be 360 minus 45 minus 113. So 360. Because that way I get that whole angle here. So 202 degrees. Ooh. All right. Okay, 34. A composite solid is shown, the top section of a cylinder with height of 3 centimeters and a diameter of 4. The bottom section of a hemisphere with a diameter of 6. The cylinder is centered on a flat surface of the hemisphere. Find the total surface area of the composite solid in centimeters, or square centimeters. Okay, so let's try and pull this apart, literally. So I can see I've got one circle here that I'll call 1. I can see I've got the wraparound on the cylinder, which I'll call 2. I've got half a sphere, which I'll call 3. And this little bit here, all right, that's that little donut shape there, if I draw out the bird's eye, what would it look like? So let's... Okay, so if I draw the bird's eye, this is what it would look like from the top. So I've got 4 across here. And I've got 6, I'll use different color, 6 across there. So all we want to find here is that little donut shape there. Now that's an annulus if you don't know, but it's literally going to be big circle minus small circle. That's going to give us that bit there. So I'm going to call that 4. Okay. So let's do this. 1 is just pi r squared. So pi times 2 squared. 2, now that curved bit is 2 pi rh. If you're not sure, really remember that from the formula of a cylinder. So that's 2 pi times 2 times 3. Now we've got half a sphere. So a sphere is 4 pi r squared. Now we're going to halve it because we've only got half. So that's 4 pi 3 squared, because it's the big one, divided by 2. And then lastly, we've got our little donut shape, which is going to be big circle minus small circle. So pi times 3 squared minus pi times 2 squared. And we basically just need to add all these up. Okay, so let's do this. So pi times 2 squared plus 2 pi times 2 times 3 plus 4 pi times 3 squared over 2 plus pi times 3 squared minus pi times 2 squared. Okay, I really hope this is our answer, but total area is 112.52 centimeters squared. Okay. Nice. All right, 35. Joe is researching the relationship between the age of teenage characters in television series and the age of actors playing these characters. After collecting data, Joe finds the correlation coefficient is 0.4564. The scatter plot showing the data is drawn. The line of best fit with the equation is also drawn. Describe and interpret the data and other information provided with reference to the context. All right, so if I look at this marking here, 4 marks probably means we need 4 points. Now I'm just going to go with a really obvious thing here. With a correlation coefficient of 0.4, I can say there's a strong, moderate, positive correlation. Positive as in, you can think of it as gradient. What else can I say? So looking at this thing here, the gradient. So what that is saying, right? It's saying for every year that the age of the character goes up, for every 1 year, the age of the actor goes up by 1.85. So for every 1 year of character age, the actor's age increases by 1.85 years. Okay, cool. Now I've actually there's actually 2 things here. So I'm actually going to call strong moderate 1, and a positive correlation 2. So this is my third point, so I'm just going to need one more point, I think. So just by looking at it, I think I'm going to say describe and interpret the data. Okay. I guess I'm just going to interpret the last point as saying it will have a y-intercept of minus 7.51. Okay, that should hopefully do it. And that's going to give me my fourth point here. 4 marks, hopefully. Okay, 36. Frankie borrows $200,000 from a bank. The loan is repaid over 23 years at a rate of 7.2% compounded monthly. The repayments have been set at $14.85 per month. The interest charged and the balance owing for the first 3 months of the loan are shown. Okay, so we've got a reducing balance loan here. What are the values of A and B? Okay, so with reducing balance loans, they work on simple interest each row. So the interest charge here is just literally going to be I equals PRN for A. So my interest is going to be 199715 times my rate, which is 7.2% compounded monthly. And my N is 1 here. $199,715 times 0.072 over 12, which is 1198.29. Getting a bit sloppy here. All right, so I'll write that over there. And B is going to be, okay, so balancing at the end of the month, it's going to be P plus I minus R. So principal plus interest minus repayment. Pretty straightforward. So that's 199,428.29 plus the interest minus the repayment. So B is equal to 19913.86. 139. Almost missed that. Okay. Question B. After 50 months of repaying the loan, Frankie decides to make a lump sum payment of $40,000 and to continue making monthly repayments of $14.85. The loan will then be repaid after a further 146 monthly repayments. How much less will Frankie pay overall by this lump sum payment? Okay, so once again, let's make a table. So let's not even worry about the the lump sum yet. Let's work out what she would repay over the life of the loan if she just keeps doing what she's doing. So I'm going to call this the original, and I'll call this the lump sum. Okay, so the original, she is repaying $14.85 per month for 23 years. So in total, she's going to repay $409,860, and I'm going to minus the principal to work out what her interest is going to be, which is 209,860. So that's the interest she pays if she keeps doing what she is doing. Okay, so for the lump sum one, it says after 50 months of repaying the loan. Okay, so let's start with that. So 50 times
1485. So 50 months, she's repaying the loan, and then Frankie decides to make a lump sum of $40,000 and continually making monthly repayments of $1,485. Now the loan will be fully repaid after a further 146 months. So really, it's going to be this number plus 146 times 1485, and then we're going to minus the 40,000 here because she pays that as a lump sum. So 50 times that is 74,250. 146 times 148,145 is 216372. And remember, I'm subtracting this 40,000 because it's a lump sum payment. So I'm going to add all the repayments. So that's all the repayments is going to be 290,622, and I'm going to take away the 40,000, which gets me at, so her total interest here is 250,622. And I need to minus, sorry, that is the total repay. Now I need to minus how much she's borrowing, which is $200,000. I think I made a mistake here. All right, so let's just back up a bit. 146 times 1485. That should be 810. Okay, so I need to redo this bit. So this should be I've got to add that back on, don't I? 331060. That's how much he pays for that. Subtract her principal. Which is 131060. Compare these two. Okay, so 209860 minus 131.0 or 131060, and it looks like to me she's saving 78800. Okay. How far are we? Oh, 2 more questions, thank God. All right, so the lifespan of a battery from a particular factory is normally distributed with a mean of 840 hours and a standard deviation of 80. It is known from statistical tables that the distribution approximately 60% of the batteries have a lifespan of less than 860 hours. What is the approximate percentage of batteries that will have a lifespan between 820 and 890? Okay, so let's once again draw one of these. So it's got a mean of 840 and a standard deviation of 80. So I'm just going to have a look at what I've got here. So I'm adding 80, that's 920, and I'm subtracting 80, that is 760. Okay, now I want to find what is the approximate percentage of batteries have a lifespan between 820 and 920. Well, 920 there is already one standard deviation away. So I'm literally just going to mark a note of that. 920 is equal to a z-score of +1. But what about 820? Okay, so to find 820, we've got z is 820 minus the mean divided by the standard deviation of 80. 820 minus 840 over 80. So that has a z-score of minus 0.25. Okay. So that is for 820 here. But it also says, I missed this sentence, it also known from statistical tables that the distribution, that for this distribution, approximately 60% of the batteries have a lifespan of less than 860. Okay, so 860 is here. Let me put in my 820 I just found actually. Okay, now, if you really pay careful attention, you'll notice that 820 and 860 are same distance either side of 840. So they're 20 hours apart. It also says here that for 860, anything less than 860, anything to the left of that, so once again, anything to the left that has a probability of 60%. So I know that the mean cuts the data at 50%. So I can actually say, right, I can actually say that here is going to be only 10%. Since it cuts 60%. And I can also say here is going to be 10% because it's symmetrical. So how am I going to make this obvious for you? So all of that is 10% there. And all of this is also that 10% there. Now I just want to know what is the approximate percentage of batteries the lifespan between 820 and 920? Well, I've got 820 to 840, that's 10%. And I know that 840 to 920 is one standard deviation. So one standard deviation is 34% if you think back to your little graph. So that means all of this here, that there, now I'm going crazy with colors here, that there is 34%. And that there is 10%. So you add those two up, 34 plus 10, plus 10%, that's going to be 44%. Okay. All right, last question. A full container of 4.8 litres of mixture of cordial and water is in the ratio of 1 to 3. After removing 1.2 litres of mixture, more water is added to refill the container. What is the ratio of cordial to water in the final mixture? Okay, so last question seems not too bad, but let's find out. So cordial and water is in the ratio of 1 to 3. Now I'm just going to make that into milliliters to make it easy to work with. So it's in the ratio of 1 to 3. So 1 to 3. Let's work that out. So I've got 4,800 divided by 4 parts. So you've got 1,200. And you've also got 3,600. So this is, let's put water here and cordial here. After removing 1.2 litres of the mixture, more water is added to refill the container. All right, so once we remove 1.6 from this, what are we left with? So we've got 3,600 milliliters left. And that's also in the ratio of 1 to 3. So let's go 3,600 divided by 4. So that's 900 milliliters and 2,700 milliliters. Okay, so more water is added to refill the container. So we need to add another. To get from here back to there, I need to add another 1,200 milliliters. So plus 1,200 milliliters of water is going to get me 3,900 milliliters of water to 900 milliliters of cordial. So what is the final ratio? So I'm just going to cut a few zeros here. Bang, 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 bang. 9 to 39. So I think that is 3 to 13. Okay, that's it. So paper done. I hope that was helpful to you. If you'd like me to do more stuff like this, please leave a comment and let me know. Or if there's any mistakes, definitely let me know, because it probably is. Yeah, I definitely have an appreciation for you guys that actually sit these 3-hour exams. I'll be uploading more stuff, especially to do with Standard 2 Maths over the next few months. And if there's any particular topic, let me know. Or, later down the track, we'll deal with the advanced and extensions. But for now, we're just covering standard. So I hope you enjoyed this. Remember, my name's Adrian. If you like it, subscribe it. Give me a like. All right.